A game involves tossing 2 coins. A player wins $1 if both tosses result in heads. What should you pay to play this game in order to make it a fair game? So again, the idea of a fair game. What is a fair game? It's when the cost to play, right, the dollars it costs to play the game exactly equals the dollars of what you expect to make in the game, the expected or average value. So that's what would be a fair game, is if they charge you to play the game exactly what you expect on average to get from the game, the expected value. So to figure out what you should pay for a fair game, to make it a fair game, we've got to calculate the expected value. Whenever they say that, we've got to calculate expected value. Remember how expected value works? You got to go through all the outcomes, outcome number 1, outcome number 2, etc. And for each outcome, you've got to figure out the probability of it times the value, the dollar value of it, plus the probability of the second outcome times the dollar value of the second outcome, etc. So each of those is a probability times the value. So, all right, so what are we doing in this problem? We are tossing 2 coins. So we're not rolling any dice, but we're tossing 2 coins. So what happens when you toss 2 coins? Let's do that. So the first toss, oops, I should have left a little more room, I think. So the first toss, let me come down here. The first toss could be heads or tails. First toss is either heads or tails. And then the second toss is also heads or tails. And so putting it all together, there's 4 things that can happen. Heads, 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 tails, tails, heads, and tails, tails. There's 4 different results. And the probability for each of these is a half, right? A half chance for heads, half for tails, half for heads, half for tails, half for heads, half for tails. And remember, you multiply and, because you're doing the first toss and then you're doing the second toss. So it's a half times a half. So when we go this road, a half times a half to end up in half-half, we multiply a half times a half to get a fourth. And then when we go half-half this way, and we get heads, tails, same thing. We multiply a half times a half, which is a fourth, a half times a half, which is a fourth, a half times a half, which is a fourth. So basically there's 4 different things that can happen. We can get heads, heads, and the chance is a fourth. Heads, tail, a fourth. Tail first, then head, chance is a fourth. Both tails, chance is a fourth. These are the probabilities, aren't they? So now we're ready to calculate the expected value. So we have to do every outcome. And what are we talking about in particular? You win $1 if both come up heads. So all I care about is if we win, that's one outcome. I'm doing the various outcomes. So outcome number 1 is we win, and outcome number 2 is we lose. We're either going to win or lose when we flip the coin twice. So how do we win? Here's winning, 1/4 if you get heads, heads, right? That's what they said up here. You get $1 if both are heads. So you win if you get, which is a 1/4 probability if you get both heads. So the probability, 1/4, times the dollars. What do you win? You win $1. Plus, Now, what's the probability of losing? Well, all these mean you lose. If you get heads, tails, or tails, heads, or tails, tails, you lose. So those add up to 3/4, don't they? 1/4, 1/4, and 1/4. That's 3/4. So the probability of losing is 3/4. And what do you get if you lose? No money at all. They don't pay you anything. So that's the expected value. Let's calculate it. So if you take your calculator, 1 divided by 4 times 1 plus, well, this part's just 0, isn't it? We don't even need to mess with that. That part's just 0. So just do the first part, and you'll get 0.25, and this is dollars. So that's 25 cents, in other words. So that's what you expect to make on average. In other words, if you play this game again and again and again where you flip the 2 coins, sometimes you'll get the 2 heads and they'll pay you $1. You'll win $1. Most of the time you'll get one of the other results, heads, tails, or tails, heads, or tail, tail, and they'll pay you nothing. So if you do it hundreds and hundreds of times, on average, this is the average, it'll be just like you make 25 cents every time. Average or expected value. So on average, you'll make about 25 cents every time you flip the coin twice. So if you make 25 cents on average, then a fair price for them to charge would be exactly 25 cents. That way, they're charging exactly what they expect you're going to make. That would make it a fair game. So that's our answer up here. 25 cents. Now in casinos, they calculate and they raise the price. They don't make them fair game. They would charge maybe 35 or 40 cents to play this game, knowing that on average, you're going to make 25 cents on average. And so if they make the price to play the game higher than 25 cents, then they know on average they'll be making money. Even though sometimes they lose, still on average they will make money. That's how casinos work. There we go.